So when it comes to E3 binomial theorem, it's all about expansion of brackets with two terms with negative or fractional powers. Such brackets, if expanded, have infinite number of terms, and their expansion would look something like this. That would be something like NC0, NC1, NC2, NC3, and so on. Similarly, I have E is here and n minus 0, minus 1, minus 2, n minus 3, and n minus 4. This is essentially basic binomial expansion. A few teachers may teach this topic and just ask you to memorize the formula or just use the formula given, but it's much better to understand this topic conceptually, and it's easier to. So the fact is, the basic binomial expansion remains unchanged, and things just get complicated because negative or fractional powers are involved. So NC0, anything to C0 is 1, thus 1. And appreciate the fact that if you write something like, let's say, minus 10 C1, which should essentially be the thing itself, like minus 10, your calculator will not be able to calculate this. Similarly, if you write something like 4 over 3, that is a fraction, to C1, that should again be the thing itself. Since NC1 is the thing itself, your calculator would not be able to calculate this too. Why is this so? This is because your calculator is programmed to only accept n as a positive whole number. And that is why this things in this chapter get a bit complicated, because you have to calculate n c to something by yourself. NC1 would be n. NC2 would be using the manual calculation of n c to something, it would be this. Similarly, NC3 would be something like this. And yeah, 3, 2, 1. The number of terms in the numerator is equals to the number of terms in the denominator. And NC4 would be something like this. And 4, 3, 2, 1. And the rest of the things remain the same. That is, just a second, a to the power 1, a to the power n minus 1, a to the power n minus 2, a to the power n minus 3, and a to the power n minus 4. And similarly, you have b too. So b to the power 0 would be 1. b to the power 1 is b, and then b square, b cube, and b to the power 4. This is how the expansion would look like, and so on. Thus, the expansion of this thing can be written as a n. This is after simplification, which I showed you how, and this would be, the third term would be nc2. So yup, and multiplied by a n minus 2 and b square. Similarly, let's shorten this up a bit. Similarly, I'll have nc3. This would be 3 to 1 and a n minus 3 and b cube. We still have this term, so this would be something like n minus 1, n minus 2, n minus 3. Since nc4, we'll have to calculate this manually again, since our calculator is only programmed to accept positive whole number and p b to the power 4. So anything to a negative fractional power can be expanded like this, and its expansion can be written simply as this, and this will can continue to be expanded in the same order. Again, you won't be um, asked to expand completely, since anything with a negative fractional power has infinite number of terms. So let's take our first example. Let's say I have 1 plus x minus 1, and I'm asked to expand up to and including, let's say, the first 4 terms. So I'll go back here using this formula, which most of you would eventually memorize or can make up there. I won't prefer making it there though. So first of all, I have a to n. So I write 1 to the power minus 1. Then I have this. I can write this as minus 1, 1 to the power minus 1 minus 1 minus 2, and then x. Then I'll have to write the third term like this. That is like minus 1, minus 2, 1 to the power minus 3, and x squared. This is the term with NC2. And then for the fourth term rather, that is NC3, just a second. It would be something like, yeah, plus minus 1, minus 2, minus 3, and 3, 2, 1, since it's NC3. And we'll multiply this by minus 1 minus 3, which would turn out to be minus 4, and x cubed. And thus, this expansion, if simplified, would be something like 1 minus x plus x squared minus x cubed. And this is your final answer, expansion. And let's take another example. What if we have something like x plus 2 minus 1? And the question is again that we need to expand to the first 4 terms. So in this case, the first and most important step is I need to rewrite this like 2 plus x to the whole power of minus 1. Why is this so? Because the first term must always be a constant. This is a very important. If you don't do so, you will mess things up. You might mess things up. Always keep this in mind. Always keep this step in mind. So, and then we'll continue with the basic binomial expansion. This formula. Expanding this would look something like this. So I have 2 to the power n. Then I have n itself, and then 2 minus and minus 1 is minus 2 and x to the power 1. Similarly, I have n minus 1, this is nc2, and 2 minus 1 minus 2 minus 3 and x squared. I have 3 terms, I need one more term. So I have minus 1, minus 2, minus 3 since it's nc3. And then I have 2 power minus 4 and x cubed. And you can continue to expand this so on. And our final answer would be something like 1 over 2 minus 1 fourth, 1 fourth x plus 1/8 x squared minus 1 over 16 x cubed and so on. I'll just leave this like this. So what if we have a fractional power? Let's say, for example, something like 1 minus x. We learned that a basic binomial expansion always remains unchanged. So the first term is a minus a power n. Alright. And then we have nc1. So we have the power itself, and then 1 minus half minus 1 is 3 over 2 minus 3 over 2. And then we have minus. This would be 1 to the power 1. And then we have minus half minus 3 half. Since this is nc2, we'll multiply this by 1 power minus 5 over 2 and x squared. Similarly, we have nc3, 3 over 2 minus 5 over 2 minus 3 over 2. And this is nc3, thus 3 into 2 into 1. We have 1 to the power minus 7 over 2 and x cubed. If we simplify this, our final expansion would look something like 1 plus half x plus 3/8 x squared plus 5 over 16 x cubed and so on. So this is all about how binomial expansions with negative or fractional powers would be expanded.